Are you curious to learn how to build a 3D printed robotic arm? Learn its components and how stuff works. Since major big companies will never tell you this secret, here is how to build one. The entire robot is 3D printed. Well, of course, some hardware parts are made out of metal, because let's be honest, who would want a plastic bolt anyway? The main idea behind this project was simple. Build a fully capable 6-axis robotic arm with a minimal amount of money and get the absolute maximum performance out of it. To make that happen, everything was designed using off-the-shelf hardware combined with custom 3D printed components. When fully extended, this arm reaches 1 meter in total length with a solid 600mm working radius. And thanks to recent updates, it can now carry a payload of up to 2 kilograms. Not to brag, but that's pretty massive when you consider a standard industrial metal robot of this size typically carries around 3 kilograms. Naturally, like anything in engineering, there are trade-offs. This arm isn't going to be blazingly fast like high-end commercial robots or arms running custom industrial metal gearboxes. But here's the reality. A single industrial actuator alone can cost as much as this entire arm. Plus, off-the-shelf industrial robots keep everything hidden inside a black box, meaning your curiosity never gets fed. Building this arm reveals every single gear, drive, and mechanism behind industrial motion. To make this accessible to everyone, there are 2 main versions you can build depending on your budget and goals. The open-loop version, powered by an Arduino setup, is the most budget-friendly option, coming in at roughly $400. It's simple, highly effective, and perfect for getting started. The closed-loop version utilizes magnetic encoders for precise positional feedback. This setup costs around $600 and delivers superior accuracy and torque monitoring. Best of all, you have complete freedom in how you build it. You can scavenge spare parts from old 3D printers or copy machines, source the hardware components yourself, or skip the hassle and grab a complete hardware kit. As for the 3D printed parts, print them on your own machine at home, or order them pre-printed directly from us. Under the hood, the arm relies on a combination of 3D printed cycloidal gearboxes, compound planetary gearboxes, differential drives, and timing belts. The cycloidal gearboxes are particularly fascinating, almost like black magic. They allow us to achieve high transmission ratios with virtually zero backlash, remaining durable and reliable for years without requiring lubrication or routine maintenance. For the wrist and final 3 joints, we use compound planetary gearboxes. They offer the highest reduction ratios in the most compact footprint imaginable, while remaining 100% 3D printable. Placing them on the upper joints gives us maximum output torque with minimal added weight. On the control side, this robot supports major industry frameworks like ROS, NVIDIA Isaac Sim, MATLAB, and RoboDK. But it also comes with its own custom software out of the box. Through our native software, you can tap into cutting-edge robotics features like vision language models, LLMs, reinforcement learning, computer vision, SLAM, depth estimation, PLC programming, and full factory simulation environments. Most importantly, it's completely plug-and-play. Within just a few clicks, your robot is set up and ready to program in Python, block programming, or, my personal favorite, no-code visual programming. What truly makes this project special is the global community behind it. People all over the world are building it. Men, women, high school students, veterans, professional roboticists, hobbyists, and total beginners. Together on Discord, we solve engineering problems, refine designs, share ideas, and hang out. It's been featured in bachelor, master, and PhD theses, high school projects, and university robotics labs. People use it to automate 3D printing farms, brew coffee, serve as AI assistants, assist people with disabilities, or mount onto mobile robots to roam around the house fetching items. Computer science students love using it to test algorithms in the real world, while engineers use it in their portfolios to land top-tier jobs. Major names in the tech space like Arduino, Bamboo Lab, and PCBWay have taken notice. Parents build it with their kids as an educational alternative to Lego, while small workshop owners use it to automate production lines with custom grippers. And let's not forget the silly applications. Picking up dog waste, justifying an expensive 3D printer purchase, or giving you a solid reason to skip the clubs, stay in the workshop, listen to good old blues, and act like Tony Stark for an evening. We aren't stopping here. We are currently developing our own custom closed-loop driver boards, which will cost a fraction of commercial alternatives. We've also built a dedicated mobile robot platform capable of transporting this arm around, and we're working on an entire ecosystem of accessories. Conveyor belts, custom adaptive grippers, vision kits, and eventually, a fully CNC machined aluminum version of the arm for those who want ultimate rigidity. Keep in mind that this video is mainly for demonstration purposes. The complete step-by-step interactive assembly manual is available on our website, where you can scroll through every single step at your own comfortable pace. For full documentation, wiring diagrams, specs, and in-depth technical explanations, visit our website at arctosrobotics.com. Make sure to check out our other videos to see real showcase demonstrations of the robot in action and jump into our Discord server to connect with the rest of the community. Thanks for watching, and happy building!